Hi guys, my name is Ratan Kumar Thakur and I'm here to discuss few interview questions regarding computer networking. This video is going to help the cybersecurity aspirants or freshers, whoever is looking to give interviews for these jobs. This will help them. So let's start. First question is from the network devices. What is hub? A hub is a network device that serves as central connection point for multiple devices in a local area network. It is often referred to as dumb devices as it broadcasts all the data to every port. What is switch? A switch is a network device that connects multiple devices within a local area network and forward data packets between them. It operates all the data link layer like at the data link layer, layer 2 of the OSI model. Unlike hub, a switch is an intelligent device that can analyze and understand network traffic. Switch can decide which computer is the message intended for and directly sends the message to that particular computer instead of broadcasting like hub. What is router? Router is layer 3 device that can connect two or more network, and it also chooses the best path for the data packet to reach their destination across different networks. So what are private IP ranges? Below are those classes: class A, class B, class C. Next question is, what is NAT? NAT stands for Network Address Translation. It is a technique used in computer network to transfer private IP address used within local network into public IP address that are routable on the internet and vice versa. NAT allows multiple devices within a local network to share a single public IP address assigned by the internet service provider. So it basically conserves the public IP address by allowing the multiple devices to use a single public IP address. What is PAT? PAT stands for Port Address Translation. It is a type of NAT that allows multiple devices within the local network to share a single public IP address. Here I have mentioned one example for that. You can refer below information. Explain the difference between TCP and UDP. This question is a short question in most of the interviews. You can say that. So TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. Both are transport layer protocols and used for data transmission over IP networks. The main difference are below. Like TCP is connection oriented, and UDP is connectionless, and TCP is error free, and it basically works on handshake, three-way handshake format, and UDP is connectionless, and here you can expect some losses in between sending the packets, and there would be some errors also in UDP, but in TCP relatively there will be no error, and it is kind of slow at as it also resends the failed data packets, and UDP doesn't resends them. So you can say there are some examples of TCP, HTTPS, STTP, SMTP, and SSH. Examples of UDP will be VoIP calls, online streaming, and you can say examples like live video streaming or live matches streaming th- are the examples of UDP. So there will be a questions on port numbers also. So please memorize these port numbers at least, and there are more. You can definitely refer different videos of mine for them. Explain three-way handshake. Three-way handshake is a method used by transmission control protocol to establish a connection between client and server. It involves a series of three steps to establish the connection. First step is sync. So client initiate a handshake by sending a SYN packet to the server. This packet includes a randomly generated sequence number to start the connection. Next step would be SYN and ACK. Here you can see the client sending a SYN packet in the diagram to the server, and server acknowledging its sync and sending its own SYN to the client, and then client acknowledge the SYN packet sent from the server. In that way, the three-way handshake process is complete and connection is established between them, and communication can start now. Explain OSI model. So there will be one questions uh, on this also. So there are seven different layers in OSI model: physical layer, data link layer, network layer, transportation layer, session layer, presentation layer, application layer. In the next slide, we are going to discuss an example of that. You will get a better understanding about it. So, question is explain OSI model with an example. So, let's consider an example of sending an email using the OSI model. So, first step is application layer. Here, the application resides in the application layer. It interacts with the user. Like, let's say you are typing email mentioning, like including subject, body, and recipients. Presentation layer determines the exact format or ensures that email message is properly formatted and encoded for transmission. It may handle tasks such as converting the message into standard format, compressing it, encrypting it for better protection. Session layer established a session between email client and email server, and it manages the session setup, synchronization, determination, and in this example, it establishes a session to send an email. Transport layer. The transport layer breaks down the email message from session layer into smaller segment known as packet or diagrams for transmission. It adds necessary information like sequence number, error checking codes, and flow control mechanism. It ensures reliable delivery of packets. Network layer. The network layer handles the routing of the packets across different networks. It determines the best path for the packet to reach the recipient email server. It uses IP address to identify the source and destination of the packets. The router comes in this layer. Data link layer. The data link layer organizes the packets into frames and adds necessary control information such as MAC address to each frame. It ensures error-free transmission between directly connected devices such as users computer and local network router. Switches come into this layer. Physical layer. Physical layer deals with actual transmission of bits over the physical medium, such as Ethernet cables, wireless signals. It converts the digital frames into electrical or optical signals for transmission. A hub comes in physical layer. So at the receiving end, the process happens in reverse order. So OSI versus TCP model. OSI model is a reference model, and whereas TCP/IP model is a practical model. The function will remain same for both, but few layers get merged in the TCP/IP model. So in OSI model, there will be seven layers as we discussed in earlier slide, and TCP/IP model will consist of four layers as application layer, presentation layer, session layer. In OSI model, get merged as application layer in TCP/IP model. What is DNS and how it works? DNS stands for Domain Name System. It is a hierarchical system that translates domain names, let's say any.com, google.com, into IP addresses, which are numerically identifiers used to locate device on the network. Here we have discussed how like is a simple example of how DNS work. The resolver. So whenever you enter a domain name in web browser, your computer or device sends a DNS query to a DNS resolver known as a DNS resolver. And DNS resolver is also known as DNS client. So don't get confused during the interview. So this resolver typically provide by your internet service provider and configured on your device. So resolution would be if the DNS resolver initiate a recursive resolution process to find out the IP address associated with the domain name which you have entered in the browser. It checks its cache first to see if it has previously resolved IP address for that particular domain. If it if not, it proceed to the next step. That would be connecting to the root server. So if resolver doesn't have the IP address, it contacts one of the root server. These root servers have information about the TLDs, which are top level domains for different domain extensions. .com, .org, .net are some examples of them. So TLD server, like once the root server respond to the resolver with the IP address of the TLD server, responsible for the particular domain extension, let's say .com. For example, here we have example like if it's a .com domain, the TLD server of the .com extension will be contacted. So authoritative DNS server, the TLD server responds to the resolver with the IP address of authoritative DNS server responsible for that particular domain. The authoritative DNS server has most up-to-date information and its associated IP address with the particular extension. Then the step would be IP address resolution. The resolver sends a query to the authoritative DNS server once it receives the IP address from TLD. Then it requesting the IP address for the domain name and authoritative DNS server responds with the IP address. Then the last thing comes as caching. The resolver received the IP address from the authoritative DNS server and store it in its cache for future use. This helps expedite the future request for the same domain name. There will be some follow-up questions on the DNS servers. Uh, the questions will be like DNS servers use TCP or UDP protocol. So you have to mention that DNS server use both uh, UDP for DNS queries and TCP for zone transfers. What is DSCP and how it works? DSCP stands for Dynamic Host Configuration Protocol. It is a network protocol used to automatically assign the IP address and other network configurations sent to the device on the network. Like DSCP works on DORA process, discover, offer, request, and acknowledgement. So DSCP, like first would be discovery. Like whenever any device is configured into the network, it's broadcast the discover message over the network, and which is then listened by DSCP servers, and DSCP server responds with an offer of the available IP addresses and other configurations like uh, subnet mask, default gateway, DNS servers. So then the clients receive multiple requests from DSCP offer if available, and after that select one, and it send this request message to the chosen DNS server for providing and acknowledging for the lease period. And last step would be the acknowledgement. DSCP respond with the DSCP acknowledgement message confirming the IP address lease and providing any additional network configuration parameter which is required. So, what is DNS and how it works? DNS stand for Domain Name System. I think we have already discussed it. Yeah, there are some DSCP related questions. What's the IP address of client machine while sending discover message? So currently client machine haven't received any IP address from DSCP, it only requesting for a source IP will be 0.0.0. Does the client know the IP address of DSCP server and to send the discover message? No, it doesn't. That's why it is broadcasting the discover message. The destination IP will be 255.255.255.255. How client gets IP if no DSCP is available in the network? So if there is no DSCP in the network, then the client will get an IP address within the APIPA range, automatic private IP address. The range will be from 169.254.0.1 to 169.254.255.254. What if DHCP server runs out of IP address? So if the DHCP runs out of the IP address, that means your DHCP server is oversubscribed. Then the DHCP server will refuse to assign an IP address until a device in the network releases the IP address and makes it available again, or lease time gets expire. Explain ARP. ARP stands for Address Resolution Protocol. It is a protocol used in computer network to map an IP address to a corresponding MAC address. The MAC address is a unique number, as you all know, assigned to each network interface card (NIC) in a device. While the IP address is used to identify devices on a network, let's discuss how ARP works. First step would be ARP request. When a device wants to connect or communicate with another device within the same network, it first checks uh, if it has a MAC address of the determined destination devices in its ARP cache. The ARP cache is a table that stores IP to MAC address mapping for devices on the network. If the MAC address is not found in the cache, the device sends an ARP request as a broadcast on the local network asking like who has this IP address. So then the device which is mapping like matching the IP address received the ARP request um, and respond with an ARP reply message containing its MAC address. So message will be directly like responded to the requesting device, not as broadcast. It is a direct message between the sender to the receiver. So ARP cache update. So once the requesting device receive the ARP reply, updates its ARP cache with the IP to MAC address mapping. This mapping is stored in the cache for future uses to avoid any repeating the ARP process for subsequent communication within the same network or device. Communication is the last step. With the MAC address obtained through ARP, the requesting device can now address the Ethernet frames with the appropriate MAC address and send the data packets to the destination device on the local network. So, what is ARP? You now know that. So, I hope you all know that it is a crucial protocol for facilitating communication within the local network. It allows device to dynamically resolve and store IP to MAC address mapping, and ensure efficient, accurate delivery of network traffic between devices. What are proxy servers? How do they protect computer network against threats? Proxy server act as an intermediary between client device and the internet. They receive requests from the client and forward them to the internet on behalf of the client. Proxy server can provide several benefits for network protection. Here's how they protect computer networks. First step is anonymity and privacy. As you all know, proxy can hide your IP address of your network. So if the IP address are masked, then the attacker won't be able to generate any communication or like attack on your network. Content filtering. Proxy server can implement content filtering policies to restrict access to certain websites or types of content. This helps the organization to enforce acceptable users policies, block malicious websites, and prevent employees from accessing inappropriate or non-work related content. Caching. A proxy server can also provide cache, and like when a client requests for the same content, the proxy server and serve it from its cache instead of fetching it uh, from the internet. So it stores the cache of frequently accessed web pages, images, and contents. This reduces the bandwidth uses and speed up the access to frequently visited websites. Load balancing. A proxy server can distribute incoming requests across multiple server or resource to balance the load. This helps optimize performance and prevent the server overload and ensures high availability. So, friends, that's all for today, and we will meet in the next video. Thank you and keep learning.